So if we want to have safe drinking water, we need to have a Safe Drinking Water Act. Really, the needs and the wants of the American people are really dictated by the laws that we have in place. And that's where the Safe Drinking Water Act comes in. Now again, when it comes to drinking water, these standards that we'll talk about are really related to the standards of, the water that you're drinking. But it is the same exact water that is in your shower, in your toilet, in your washing machine. So just keep that in mind. I'll keep talking about glasses of water and what you're ingesting, but this is really just the water that you and I come in contact with. So the Safe Drinking Water Act wasn't passed until 1974. 1974, like that's ridiculous. We had some laws before then. They really weren't that strong. And I'm not saying that in 1973 our water was so bad it would kill you. No, people have been drinking tap water for forever. It's just we didn't really have standards in place and we didn't have repercussions in place. And so in 1974, the EPA, or the Environmental Protection Agency, passed this law, that Safe Drinking Water Act. And the point of this law was to set standards across the United States and telling all of the states, you need to make sure that the water going to this person's house and this person's house is of high quality, that if it has pollutants, it's at such a low level that they're not going to hurt anyone. So the main goal is essentially monitoring and controlling for pollutants at drinking filtration plants. So these drinking filtration plants, their job is to take water, whether it's surface water or groundwater. They take that from the environment and they clean it up. Now, depending on where you're getting that water from is going to affect, how much cleaning you need to do. If you're getting your water as a city, if you're getting water from some high mountaintop that only has snow melt and is the finest spring water of the land, you might have a pretty low level of filtration. Or if you are a big city that is at the end of a river that has maybe 30 other cities upstream of you, your water may be a little dirtier, so their filtration plants do a lot more. But regardless, whether you have really clean water before or after, or in the high mountains or in a low stream, the EPA is saying no matter where your water comes from, this city, this town, this state needs to make sure that that water meets the same standard. And doing that by creating different ways of cleaning our water. Now, with that said, though, although it is doing pollutant monitoring for our drinking filtration plants, it doesn't include everything. So people who have a private well, and a private well is just characterized by a well that serves less than 25 people. So maybe it's a well in your personal house. If you or someone you know has well water, this might look familiar. If it's maybe you and a neighbor and another neighbor all sharing a well, it doesn't matter. If it's less than 25 people, the EPA doesn't come out and regulate it. The EPA doesn't come out and inspect it. Typically, people who are on well water or typically on drinking water, that's what this is. It's your own private water line access. The EPA just can't reach them. Typically, these are people out in the middle of nowhere where there's no major system going on. There's no way that the EPA can go to all of these remote locations in the United States to check your individual water. Now, with that in mind, that's about 10% of the U.S. population. The United States has about 300 million people, so that's about 30 million people that don't have pollutant monitoring. So what do? Well, if you're one of those people, you, the consumer, the person drinking that water, you are the ones responsible for getting your water checked. There's tons of private companies out there, and typically if you're out in the middle of nowhere, there more than likely is some person in that area that does this because you want to make sure your water is safe. Now, in your own personal well, you might have some filtering, but again, you don't really know if it's safe enough unless you do the testing yourself. But for 90% of the rest of the population, the EPA has these standards in place, and your drinking filtration plant is making sure that they are reaching those standards. The last thing that the Safe Drinking Water Act does not regulate is bottled water. Get that? Bottled water is not regulated. And I stress this so much because drinking bottled water is not necessarily better for you. The bottled water that you drink, no matter the brand, is regulated by the FDA. Now, if you're Nestle or if you're Fuji or whatever brand, obviously you want to make your drinking water safe. You want to get people to keep buying it. But with that said, they're not held to the same standard. And as we learned about the FDA, although the FDA will say, yeah, Fuji, you can sell your water, FDA is never going to look at that water again unless someone complains that something's going wrong. So just because it comes in a bottle does not mean it's better. It can be. I'm not trying to say that it's definitely worse. It totally could be better. But it doesn't have to be. Their standards are a lot different than the EPA standards, and they're not checked. There's no kind of pollutant monitoring that is ongoing with bottled water, where there is for our tap water. So what exactly is the Safe Drinking Water Act looking at? We know it's monitoring pollutants at our drinking filtration plants. We know that's helping over 90% of the US population, but what exactly are they looking for? Well, they're looking and addressing 90 different chemicals. They are doing all these different processes in order to make sure that those 90 different chemicals are below the safety limits. And I emphasize below the safety limits because it's really impossible to get rid of 100% of anything, but we can get rid of a lot of it. You and I are exposed to pollutants every time we walk outside, human-made or nature-made. It's okay if we're exposed to pollutants. We just need to make sure we don't hit a certain level because that's when it starts affecting us. So again, this act's looking about 90 different chemicals. One thing that it looks at, which isn't quite a chemical, are microorganisms. So essentially different plants and animals can make us sick. For example, E. coli. Usually when there's some sort of E. coli outbreak, we think about foods, but E. coli can be in our water as well. So one of the things that a drinking filtration plant will do is kill any kind of microorganism. The way they kill that microorganism is using a disinfectant. We insert chlorine into our drinking water, but then we need to remove it because you don't want to be drinking chlorine, I don't want to be drinking chlorine, but we still need it. We still need that chlorine to kill everything else. So we have this disinfectant, but we need to make sure we get it back out of our drinking water. It's looking at just different chemicals, and there's a long list of them, but think of things like mercury, lead, even pesticides are regulated because we realize pesticides are getting in our waters. So we recognize, here's all these different chemicals, let's make sure we get them out of our water. Now, although it's currently regulating about 90 different chemicals, we've identified hundreds more in our drinking water. In our drinking water, we actually measure all sorts of things. But there's only 90 where we actually say, hey, you can have 1 drop of mercury and 2 drops of lead. Those have standards. All the hundreds of other chemicals don't have standards. We're still measuring them, but honestly, we just don't know like how much is okay. Is having this much of chemical A okay or not okay? And it's currently being tested. There's a list of about 100 different chemicals that are in the waiting list. They're undergoing research so that we can develop a standard. Be like, oh, chemical A, well, as long as humans aren't getting more than 5 drops in a glass of water, they'll be totally fine. That's what we're working on now. So in a couple years, this number may change. Instead of having 90 that have regulations, we might have 95. So it's constantly evolving. So what a lot of people ask is, can I drink my tap water? Is it safe to drink? You hear a lot of people who are like, oh, I won't drink tap water. If you're in a big city like we are, being in the DMV area, it's totally fine. We'll talk about some problems if you're in a more rural area. But as I mentioned before, there's going to be pollutants in our water. No matter what, we can't get rid of all of them. For the most part, not going to harm us at all. Our body's going to break them down, we'll pee them out, we'll be on our way. But even our drinking water sanitation people say, hey, our water might hurt sensitive people. And by sensitive people, this could be young kids, this can be elderly, these can be people who have HIV or AIDS, people who have had an organ transplant. But we're not saying don't give water to these guys. It's just saying that you might see they're having a reaction, maybe they kind of put it as a warning. But as a healthy adult, like, just drink tap water. Don't invest in bottled water. Just drink tap water. You'll be fine. It's more of those other groups where it's like, well, maybe we'll invest in a water filter. Maybe we'll get this. Maybe we'll get that. But as a healthy adult, there's really not too much of a reason to not just drink the tap water, especially in our area. So that's one side of the Drinking Water Act is, hey guys, you're getting water out of groundwater, out of surface water. Make sure it's clean enough for the American people. The other side of the Drinking Water Act is to prevent that water pollution in the first place. But not just any water pollution, specifically groundwater pollution. We do have different laws in place to protect surface water, but we'll talk about them more later. So the Safe Drinking Water Act is looking to prevent groundwater pollution, which again, 40% of the American people get their major water supplies from groundwater. So what the Safe Drinking Water Act does is they have a whole permitting and regulation system for injection wells. These two graphics give you an idea of what an injection well is. It's literally like a tunnel that goes through the ground, or a well that goes through the ground. But instead of this well being like well water trying to take things out of the ground, these type of wells are typically to put things into the ground. For example, waste. This is quite an actual common waste, or common way to get rid of waste. A company will literally just drill down, make this tunnel, and then put all their waste into it. Now this tunnel, I will say, it is reinforced. It usually has concrete and some sort of metal just to make sure that it doesn't leak into the environment. And specifically, we don't care if it leaks into all this bedrock. Like, we're not using the bedrock for anything. No animals live down there, no organisms, we don't care. But what we do care about is this region right here. It says it right here, drinking water resources. With the Safe Drinking Water Act and what the EPA want to do is make sure that this area of your well that goes through a drinking water source is super duper protected, that it's not going anywhere, that the waste that you are putting in this well is not going to potentially leak and enter the drinking water source. But again, they're only doing this for groundwater. They're not regulating surface water. Now, on the same premise, septic tanks. We'll talk more about how septic tanks work in a little bit, but in general, a septic tank is on a small scale. This would be something in your backyard that is where all of your wastewater goes. So instead of going to a wastewater treatment plant, it's going to a septic tank. Well, septic tanks are underground. There's a potential for that septic tank to leak into the groundwater. And so the EPA is going to make sure and have some standards and regulations related to septic tank usage on the residential and industrial scale.